Hey everybody. Today we're going to spend some time going over the assignment that is in the Google Classroom labeled as 1.4 Angle Measure Practice 1. So I thought we would go through this since we're coming up on the test day, so probably a good idea to go through some of these. Okay, so the first part's asking us to name the vertex of each angle. The vertex will be the point by which the rays are coming out of, their endpoint, those rays' endpoints. So for example, angle 4, which is right here, the vertex obviously would be T rather. Point T. Angle 1 down here, the vertex would be W. Angle 2, the vertex would be V. And angle 5, it would be T as well. Okay, name the sides of each angle. So angle 4 is right here, so this side here and this side here, so ray TU. We have to be careful with our notation, make sure we're writing this properly. So ray TU and ray TS. Okay. Angle 5, we're going to have ray TS and ray TW. Okay. And then we have angle STV. So STV. So this angle here. So this is a ray and that's a ray that's making it up. So TS and TV. Okay. And then we have angle 1. So here we have WT and WV. WV, there we go. Okay, then we have to name some of these angles. So another name for angle 3. So angle 3 is right here. So let's use the 3 points from W to T to V. We could also call it angle VTW. It doesn't really matter. Angle WTV. Angle 4. All right, we could use these 3 points, UTS or STU. So UTS is what we're going to use. Okay, and that covers the first side. Let's flip it over. Oh, is that it? Nope, here we go. Let's make sure I got the right one. Yes, this is the right one. Okay, cool. So number 12, it kind of cut off a little bit, so we're going to be using the same one, so I'll kind of put it here. So angle 2, which is right here, so this is going to be, we'll call it TVW, I guess. Angle TVW. Then we want to classify these as right, acute, or obtuse. So NMP, so NMP is right here. It's a right angle. OMN, so OMN, so right here. We know this is less than 90 since this larger one is 90, so that has to be acute. Since acute angles are less than 90. QMN, so from here to here, so this angle, clearly that's greater than 90, so that's going to be obtuse. And then QMO, so QMO. So this is one of those problems here, QMO, we're not given a measurement. We know this is less than 90, we know this is less than 90. We don't know if this exactly is 90. If you look at it, I guess if you look at it, it's slightly greater than 90, so I'm going to call it obtuse, but it's not a great problem, to be honest. That's not a good one. Anyway. All right, let's take a look at these. Let's zoom in a little bit here. So we have in the figure BA and BC are opposite rays. Okay. Ray BD bisects EBC, which means it bisects this angle. Okay, that means those are going to be congruent. And then angle EBC, sorry, ray BF rather, BF bisects AB. So that means these two are going to be congruent as well. Okay. If EBD, so this one here, is 4x plus 16. And then DBC is 6x plus 4. Find EBD. All right, so we know this is bisected. We know that means that these two angles are congruent, which means we can set these two expressions equal to each other and solve for x algebraically. So we're going to say 4x plus 16 equals 6x plus 4. And I can say that because I know that the measure of angle EBD is equal to the measure of angle DBC. I should have written that first, to be honest. So yeah, we know this because this is bisecting the larger angle, therefore these two angles have to be congruent. That's what allows us to do this. Okay? So we're going to get the x's on the same side. We're going to subtract 4x from both sides. And then 6x take away 4x will be 2x. So we'll have 16 equals 2x plus 4. And then we're going to subtract 4 from both sides. So 16 take away 4 is 12. And 12 equals 2x. And then we're going to divide both sides by 2, because that's our coefficient. And x would be equal to 6. Okay? But is that it? No, we have to find EBD. So we have to plug this in. So EBD is here. So 4x plus 16. We're going to plug in 6 for our x value. So 6 is going to go here. Let's follow our order of operations. So we're going to multiply first. So 4 times 6 is 24, plus 16 is 40. So 40 degrees, and that's the solution there. Okay, using the same figure, ABF is 7x minus 8. So ABF is here. This is going to be a very similar problem, 7x minus 8. And then EBF is here. That's 5x plus 10. And very similar, so this is bisecting the larger angle, which means these two angles are going to be congruent to one another. So it means we can set this up algebraically and solve it. So we have 7x minus 8 equals 5x plus 10. We're going to solve for x. So I'm going to subtract 5x from both sides. And that's going to give us 2x minus 8 equals 10. All right, now we just have a two-step equation here. So we're going to get rid of our constant. We're going to add 8. We're going to use the inverse operation here. 10 plus 8 is 18. And then 2x equals 18. And then we're going to, again, get rid of our coefficient, which is 2. Divide both sides by 2, and x will be equal to 9. But we're not done yet. We need to find EBF. So EBF is here, so we're going to plug it in here. So 5x plus 10, 5 parentheses, plus 10. What's going to go in there? 9 is going to go in there. We're going to follow our order of operations. We're going to multiply first, so 45 plus 10, and that's 55 degrees. Okay, so that's how you do the first sheet. I was planning on doing the second one in the same video, but I'm running a little late, so I'll try to get that done tomorrow. So we're coming up on the test day, so please let me know if you have any questions on this content, guys. All right, thank you.